Well, because we have seen how we get the mass deficit or the mass defect, now it is important to realize how this truth led us into the understanding of how we harvest the nuclear energy. This mass defect or the mass deficit comes about because some of this mass is converted into the binding energy of the nucleons. Remember, the nucleons, these are the particles that we find in the nucleus of an atom. It comprises of the neutrons and the protons. How they fit inside the nucleus of an atom, it is energy, what we call the nuclear energy, that binds and holds together in that small tiny space inside the atom. Now, to sum it all, the mass deficit is because the small amount of mass has been converted into energy that is used to hold together or to bind together these nucleons in the tiny space that is the nucleus of an atom. Well, we are going to do an example to find the binding energy of helium. Now, the helium chemical element is as shown below here. There are 4 nucleons inside, that is 2 neutrons and 2 protons. Now, the starting place is first finding the mass deficit of helium. Now, what we call the mass deficit. To get the mass deficit, we need first to put on a scale this helium, the helium atom. We put it on a scale, and we get the total mass, that is we call it the measured. We get the measured mass of helium, and if we measure the measured mass of the helium, it is 4.002602 atomic mass units. Okay, now if on the other side we get the two nucleons, that is the 2 protons, and we get the 2 neutrons together, and we add the 2, one proton weighs, that is 1.007276. that is the mass of one proton. Now, but there are 2 of them, so we multiply by 2 and we get the total mass of the protons in the nucleus of helium element or helium atom. And then on the other side we add that to the mass of a neutron. A neutron weighs 1.008665, and there are 2 of them, so again we multiply by 2. If we multiply by 2, then we get also, that is the calculated mass of the neutrons. So once we multiply, that is the proton mass, by 2, we get this number here, and once we multiply the neutron mass by 2, we get this value here. Now, the total mass of the nucleons, total mass or total that is calculated mass of the nucleons now is, we add the mass of the protons and the mass of the neutrons. So the total calculated mass we get is 4.031882 atomic mass units. Now we need to compare. We compare now what we call the measured mass, and here we have what we call the calculated mass, and we subtract the 2. We are finding that the calculated mass happens to be higher than the measured mass. Now the difference, which we call the mass difference, we are going to get it here, and we said in the previous lesson that the mass difference results from that small amount of mass which has been converted into binding energy that holds the nucleons together in the nucleus. So here the mass difference will be 4.031882 minus 4.002602, and the answer is 0.029276 atomic mass units. Now that is the mass difference, and again, don't forget, this small mass difference has been converted into energy that holds together or binds the nucleons inside the nucleus of helium atom. Now from there we need to find the binding energy. Having known the mass defect of helium is 0.029276 atomic mass units, and we know the fact that 1 atomic mass unit is equals to 931.5 mega electron volt. So then we can say our 0.029276 we multiply with 931.5 mega electron volt. After we multiply this one, and you get the answer to be 27.3 mega electron volt. So that would be our binding energy. This is what we call the binding energy of helium. Okay. The binding energy, we need to use the Einstein's energy mass relationship formula, that is E is equals to mc squared. E is equals to mc squared. Now before we have used this formula, we need first to get this value and convert it into kilograms. That is the basic SI unit for mass. To convert it to kilograms, this will be 0.029276 we multiply by, that is 1.66 times 10 to power negative 27, and then we get our mass in kilograms, and the answer here will be 4.859816 times 10 to power negative 29 kilograms. So the thing we need to do is to find the binding energy. To find the binding energy, we say now energy is equals to, this is the formula we're going to use to write it in a better way. Change in energy is equals to change in mass times c squared, where c here is the speed of light. Change in energy here will be equals to 4.859816 times 10 to power negative 29 times 3.0 times 10 to power 8, and then squared, right, which is 4.859816 times 10 to power negative 29 times 9 times 10 to power 16. So we get our answer as, and the answer here is 4.3738344 times 10 to power negative 12 joules of energy. That is what we call the binding energy. To convert this value into what we call electron volts, and the answer here will be, that is 2.73 3 times, sorry, it should be 4 times 10 to power 7, that is electron volts. Now to make it mega electron volts, we can divide by 1 billion, and that would be 27.34 mega electron volts. This is what we call heliums. That is helium binding energy. The known value for helium's binding energy happens to be 28, that is approximately 28 mega electron volt. Okay, now we need to account for this difference, this error in our calculation. The uncertainty in this calculated value here, it is because of our inconsistency in the number of significant figures. For instance, this number here, if you work out in your calculator, it should have been 4.860, and then there's some values. If we are consistent with this value here, therefore it means that the number that we got here, it shall be rounded off to approximately 28 mega electron volts. Now you need to be careful here, okay? You need to be very careful when dealing with the topic on binding energy. The number of significant figures are very key. use consistent values and the other thing is that make sure that you don't mess up with these decimal places. It's very key. And don't again use very few significant figures. Binding energy per nucleon. Now, as we said, that binding energy means the energy that binds together the nucleons within an atom or within the nucleus of an atom. That is what we call the binding energy. If we want to know per nucleon, then that means we need to know how many nucleons there are, and then we divide the total amount of energy over the number of nucleons. In other words, we are saying we need to get the total binding energy divided by the number of nucleons. That's what we call the binding energy per nucleon. That is how we get the binding energy per nucleon. Now back to our example. We said the exact value for helium, that is helium-4, its binding energy is approximately 28 mega electron volt. So if you want to know what we are calling the binding, that is the binding energy per nucleon, that is nucleon, then it will be equals to 28 mega electron volt. You divide by their 4 nucleons. Now remember, nucleons means protons plus neutrons. So there are 2 of them, and there are two protons, and there are 2 neutrons. Now these sums give us 4 nucleons. So if we divide the total binding energy of the helium atom by the total number of the nucleons in the nucleus, we are going to get what we call the binding energy per nucleon, and this answer is 7 mega electron volt.